Look, I'm just a geologist. I like rocks. I love rocks.
All right. Hello, everybody, and welcome to the Geology Flannelcast. My name is Steve.
Hello, everybody. I'm Chris.
Hello, I'm Jesse with the energy.
Yes.
You just ramped right into it. 3, 2, 1, and I had no time to think.
I'm sorry. Well,
That's what I need.
yeah,
that.
exactly. We got to throw him right to the firing squad. There he is.
Yeah.
All right, everyone. Welcome to the Geology Flannelcast. If this is your first time listening, welcome. How you doing? Glad to have you here. If you're a repeat listener, welcome back. Thanks for coming back to the premier geology podcast.
Yes, the premier geology. I cannot say enough good things about this podcast. I may be slightly biased, but
No, that's a great endorsement. I'll take your endorsement. I feel like we lost the mantle of premier there. We're back on top.
we did for a little while. We tailed off in that we didn't record for a few years, but we're back. It turns out we just forgot to hit the record button. We learned our lesson. And
my whole computer wasn't even plugged in.
Jesse was just talking to a wall. Good times. Yeah. So, here we are today. We have a bunch of...
This is episode 73?
It is.
73?
70, I think, yeah, 73.
That's crazy.
I know. We've been going strong since last April.
Which is incredible. Like, this is the most consistent we've been since 2014, I want to say.
Consistent thing I've ever done in my life.
That's good. That's a good point.
There you go.
Yeah. You have been married for longer than that.
Yeah,
but
that is correct.
I'm on my 8th marriage, so
inconsistent.
But eighth one's the charm.
Let's hope for your bank account.
Love you, dear.
All right, you wanna jump into it?
Yeah, let's get.
We got some current events news stories today. Got some cool ones. We were talking about this before the show started. We actually have an idea of where we're going with this today, so it won't be all controlled chaos. It'll just be.
We do.
Yeah,
Wait, what?
we do.
Man, I wasn't listening to you.
We all talked about this. You were in the conversation.
I blacked out again. Sorry.
See what I have to deal with week in and week out, people. All
right. So I have a interesting old story, if you will.
All right. Let's go for it.
So this is from some of the National Geographic's 10 awesome science discoveries you may have missed in 2020 because,
so December, year's wrapping up.
2020 may have been slightly distracting with all kinds of stuff.
I've never felt more alive in my life.
So billions and billions of years ago, 13 plus billions of years ago, the universe started, right?
Allegedly.
Yeah, 13.
Yeah. Yes. And in that creation, some stuff got blown out into the universe and coalesced in dust and other rocks and things like that. And then there was this Mccurtion Meteorite, which lit up the skies over Australia in 1969.
So fast forward a little bit.
Yeah. So fast forward about 13.7 billion years later, this meteorite lit up the sky over Australia and it careened to the surface of the planet. And they actually analyzed the rocks from this meteorite, and the particles on this rock are actually older than the planet, which is really, really cool. So these are the oldest things on the planet. They're 4.6 billion to 7 billion years old. So
that's old. And real fast, Steve, Mccurtion Meteorite, that's just the name of the meteorite. It fell near the town of Mccurtion, Victoria in Australia.
Yeah, who doesn't know that, Chris? Come on.
I had to look
I
it
thought
up.
that was common knowledge. That's why I didn't. That's why I didn't bring it up.
Very, very smart listeners. And
Good day. Come on. Thanks to all our Australian listeners out there.
It's a big meteorite. Wow, this thing's over 100 kilograms in weight. That's pretty heavy.
Yeah.
What?
220 pounds.
Yeah. What is that in pounds?
220.
Phew. That's that's like if I fell to the earth.
Yeah, I was just going to say, that's exactly what I was going to say. If me and or Jesse fell to the earth, or some slightly larger Chris fell to the earth.
In the town of
Mccurtion,
Victoria. What type of meteorite is it?
It didn't say. I'm assuming, or at least in this article that I'm reading, it didn't say. So I'm assuming it's a.
It should have been. It's a chondrite.
Yeah.
Okay.
And again, I'm reading the Cliff Notes version of this article, but I believe it was zircons that were dated in this meteorite to date it to that age. So, just pretty cool that there's stuff on the planet that fell geologically like super recently that are technically older than the planet itself. So
Yeah.
So go ahead, Jesse.
I was going to say zircons. Zircons are just they're a type of silicate, and they're super resistant to weathering. So when we think about dating the oldest minerals on Earth, they're usually zircons because they just resist breaking down.
yeah, they just hang out forever. Other things just eventually weather, break down into other things, but these things stick around.
Did you were you going to talk about what a chondrite is?
Yeah.
Go for it. And yeah, I could see that the chondrite gleam in your eye.
No,
I could tell.
I know we've very smart listeners here, and I don't take offense if you know what this means. No, but a chondrite is there's several different types of meteorites, and a chondrite is what's known as it's a stony meteorite. And that's all I want to say.
Oh.
It's just,
I was settling in for a long lecture.
No, and most of the meteorites that hit the planet are iron-ish chondrites, iron nickel type chondrites. They're rarer, much more rarer carbonaceous chondrites that can hit the planet. They're usually they're actually usually broken off of other planets as opposed to primordial, like super old iron chondrites. So
I've heard, so yeah, we in a very general sense, you can have stony meteorites or iron nickel meteorites or some mix of stony iron. And I once was told that, just roughly looking at the meteorites that have been found through history, the ratio that we found of those is the same ratio that makes up the Earth in terms of the core is iron nickel, and the crust is stony, and the mantle is sort of a mix of both. I've never looked into it. I sort of took it out, I forget where probably some professor as an undergrad told me that, and I was like, that's really cool. But that makes sense. Like if you think about, this is the material that, this is just leftover pieces of, accretionary material that made up the Earth. It would make sense that the makeup of the Earth or the composition of the Earth is similar to what we're finding still crashing into the Earth. Just something I always thought was sort of interesting, but maybe it's just me.
No, it's very interesting. Of course it is.
Yeah,
I just need affirmation. Just tell me.
No, it's funny because I was always under the impression, and again, I haven't looked into it much either, that iron meteorites were much more common than carbonaceous meteorites, stony meteorites. But then again, it may be that iron meteorites are much more easier to find, I guess. because they are slightly different than the crust. So you can legit just walk around with like a magnet
Yeah.
Well,
and pick
I mean,
them up.
how one of the best ways to find a meteorite is to just walk around in Antarctica.
Yeah.
So on top of the snow. So if you see any rocky type features sitting on top of the snow, it's a meteorite.
And I once read an article about how there's something to do with the magnetosphere, and there's a slightly more probability of an asteroid hitting Antarctica or the Arctic based on the magnetosphere. But that's, I'm not going to get into that because I didn't really quite buy into it and or believe it. I thought it was just like, hey, you have this giant white landscape.
Yeah.
Anything dark is going to be from outer space.
That's what I always thought. Yeah, I mean, like, because basically nothing happens on the surface of Antarctica.
Right. And you think about it, all the stuff that hits the ocean, well, that's a loss. Anything that hits the surface of the planet, if you're not in some sort of like Saharan desert or something, you're not really going to notice it.
Yeah, it's going to weather and break down pretty quickly.
Right.
Mm-hmm.
So, yeah.
Well, I don't know if I ever showed you fellas this. Let's see. I mean, for the podcast listeners, you're out of luck. But if you're watching this on YouTube, so I have here, this is a piece of a meteorite. And supposedly this is from the 2013 Chelyabinsk.
Ah,
in
nice.
Russia. So I don't know if this is like legit or not. I don't know. I got it at a mineral, what's it called? Like one of those like gem and mineral shows. You can buy all the minerals and stuff like that. And I bought a couple meteorites, and the lady was like, "Oh, here you go. This is from Russia in 2013." And I was like, "Are you serious?" And she's like, "I don't." And I was like, "Yeah, close enough. All right, I'll take it." So I don't know. I saved it. I don't know if it's real or not. But.
That's interesting. There used to be this small shop in the town I'm from, and the guy who ran it does meteorite procurement. Like he buys and sells meteorites. And I remember I went in a couple of years ago when he first opened, and I was talking to him because we had a common interest. And he gave me a stone. He's like, "Yeah, this is probably a meteorite found in the Sahara in Morocco, maybe, I don't know." And it's been sitting on my shelf in my office at Temple, and I've been meaning to. I want to cut it in half and test it and see if it really is. I mean, it's magnetic, and that's basically the one guy he worked with in Africa. That's how he goes around just with like a neodymium magnet, and when he finds like these super magnetic rocks, they just sort of make an assumption.
Yeah.
And so I'm like, well, that's you're making sort of a leap there, but I guess it sort of makes sense, given what the geology. I don't know enough about North African geology to make that claim, but yeah, I really want to cut it in half, as we do often when we get rocks.
Yeah,
just cut it up.
Similar situation happened to me when I was at Temple. A student came in with a rock that they had pried out of a coral reef. Like, it was a coral reef in Florida, and there was this big iron concretion in there, and they assumed that it was a meteorite because it was just this big chunk of iron in this coral reef. And they dug it out and brought it up to Temple, and we cut it in half, and you do these various tests like acid etching and all these things to look for this very specific pattern of mineral growth. If it was grown over millions of years, they call it Widmanstraten. But the other alternative scenario was that it was like a cannonball from
wasn't it from
Revolutionary War or something? Yeah. So as it turned out, it did not have this Widmanstraten pattern. So it had to go through additional testing to figure out if it was a meteorite.
You know,
We had a teacher who he had this famous line, because as a geologist, people always ask you, I think I got this meteorite. And, honestly, 90% of the time, it's when people ask me that, it's not a meteorite. I was just asked that a little while ago, a couple months ago, actually. Somebody came up to me, I got this really interesting rock. Can you look at this? Is this a meteorite? We call those meteor wrongs.
Yeah.
We last spring, before we shut down, these guys came into our department because they thought they were fishermen off the Jersey Shore, and they would go all the way up to Georges Bank, up sort of off the coast of like Nova Scotia. And they had some really interesting stuff. They had this really old ceramic like vessel of some sort that had like a single like maker's mark on it. And they're like, do you know what this is? And I was like, oh boy, I wish. That it's like really cool. Like, you got to talk to someone in like archaeology or something. It looks old. That's my opinion. But
that's good.
They also had a rock they thought may have been a meteorite because it was magnetic.
Mm-hmm.
But here it was like only magnetic on certain parts of it. It was really strange. And here we sort of pieced together, kind of looking at it, that it was these little veins. I guess it had washed off probably the Jersey Shore. These little veins of magnetite had infilled into what was otherwise, I don't know, sandstone or something. It was kind of interesting. It was cool because it just all looked the same, and you put a magnet on it and it would just stick to it. But if you move the magnet a little bit to the left or the right, it would just fall off. You're like, oh, that is very interesting.
That is very interesting.
Anyway, it was a meteor wrong. That's what I took. I took the rock and just chucked it in the garbage can. I didn't. I said, this is still a really cool rock. And he lost interest really quickly. When I was like, wait, let me tell you why this is so interesting.
Yeah.
Yeah.
Like, you can have it if you want. No, he kept it. But I like meteor wrong. I'm going to start using that more.
You never heard that before?
I don't think so. Maybe. I feel like you've told me that before.
That's that's an infamous Doc Meyer quote right there.
Yeah.
Nobody else knows who he is, so we'll stop with that. But cool. I got an idea for a story.
Can we pay some bills real quick?
Yeah, it's right there. Yeah. I'm sorry.
No, that's fine. We've taken to paying the bills mid podcast like we're professionals. So we'd like to thank the Formatting Formula, www.formattingformula.com or YouTube/C/Formatting Formula, for being a wonderful sponsor of the podcast. For any of your Word formatting document needs, please check them out. They have this vast number of YouTube videos where they actually explain everything step by step. And when I say step by step, I mean like slowly, calmly, like legit. And they have different versions of Word. So even if you have an old version of Word, you can go check on those videos to figure it out. They do it step by step and very slowly to the point where like you can legit follow along as you're doing it. And obviously it's a YouTube video, so you can still pause it and then do what you're doing and then go back to it. But I can't say enough about them. They've helped me out. I don't know. I'm going to say a gazillion times. That's probably slightly close to an exaggeration, but it's probably closer to the realistic number. But so check them out, formattingformula.com or YouTube/C/Formatting Formula. Tell them the Geology Flannelcast sent you, because let's face it, they're keeping the lights on.
Well, actually, I have an impromptu. I just thought of this. The Formatting Formula sent us a listener question.
Uh-oh.
What?
related to meteorites.
No.
What?
I swear to God, this is like the smoothest transition we've ever had on this podcast.
Yeah, you could have mentioned this before we went on air, but no, I'm liking it. Carry on, Chris.
all right. Here we go. No, this is a fun question. So they ask, is there always a sonic boom when a meteor passes through the atmosphere, as it did in Rochester, New York today? So I guess when was this? This is from December 3rd. So this is a little bit more than a week ago. And does it disintegrate when doing so?
Ooh.
So, is there always a sonic boom? Well, these things are moving pretty fast.
Yeah, they're moving
And-
pretty fast. So I
yeah,
want to say
and
there's
it's-
always a sonic boom, right?
I would say so, and it's not until it passes into the Earth's atmosphere. Yeah, I know the larger, like I don't know about like some like the smaller stuff, but I know like the larger stuff, these larger asteroids that hit the Earth and cause like a lot of stuff to die, they're coming in at like Mach 50. So I would say that passes the threshold for a sonic boom. I think
Yeah.
at
Mach
that point,
1 is
yes.
sonic boom. Yes.
So 50 like ish, 50 times the speed of sound. And I think at that point, the sonic boom rattling your windows is the least of your concerns. If,
But that is a good question. Once you break the speed of sound, is there something physically that happens to you? Like when jets break that speed of sound, is there a shaking, a rattling, like to the jet itself, or to the person, to the thing?
I think a big thing is air resistance and friction once you're going that fast.
Yeah. So the sonic boom is it doesn't only occur right at when you break the speed of sound. It's actually continuous because it's a shock wave created as they're moving through. Like you were saying, there's air resistance, and so but it sort of depends on where the observer is relative to where the object is moving, and there's geometry involved in the shape of the sound wave or the shock wave that's being created. It's like a cone, basically.
Mm-hmm.
It's a cone region, and you have to be behind it to briefly experience the boom as it goes past.
So if you were also moving at the speed of sound, you would
hear it?
constantly hear the sonic boom.
Oh, gosh. Yeah.
So I
That
got
hurt my brain just thinking about that one.
Yeah.
But to answer the question, does the sonic boom actually break up the meteorite? I would say no.
It's
Correct.
the friction.
Friction, yeah.
Right.
Yeah,
it's the
I mean, it's the
friction.
same
It has
thing-
nothing to do with that 600 feet per second. It has to do with the friction of the atmosphere heating it up and breaking it up. It has,
Yeah,
the sonic boom itself doesn't actually boom anything. Correct.
Yeah, 'cause it's just it's traveling. It's the way it's like compressing the air. It's creating a shock wave.
Okay.
767 miles per hour.
Yeah, about 600 feet per second.
Yeah.
Right.
Give or take.
I don't know. That's what I remember from high school physics. Let's put it that way.
Oh,
That
sure.
was 20 years ago,
Well, you're a little off.
25 years ago. What is it?
1,124 feet per second.
Yeah, 1,124 feet per second, like I said.
Like you said.
Ah, come on. Am I off by that much? Wow.
Maybe it's changed. The Earth has sped up. The air got
In the last 25 years, yeah.
the air got thinner.
So I didn't hear about this this meteor coming through the Earth's atmosphere early December. So it was on what they're asking is a meteorite strike on December 2nd, 2020, around a little bit after noon, and it was seen from New York, Ontario, and Maryland. Wow, this thing was cooking. So yeah, they saw it as far south as Virginia and as far north as Ontario. So,
Wow.
yeah, right.
Yeah. Well, so
Like
yeah, this super extended commercial for the formatting formula. Thanks for that awesome question.
Yeah.
And like legit, I had no idea this question was coming. So thanks, Chris, for that.
Yeah, if they, that's how you can get us to extend out if you want to be a sponsor.
Oh, that's true. Yes.
You wanna
Become a
be-
sponsor and then throw us questions at Chris, and then he won't tell us. And then we'll just extend your formatting. formula.
Here's the deal. I need to keep these guys on their toes. right?
Absolutely.
So
Yeah.
That's
Yeah.
just what's going on there.
I hear you.
It's working.
Yeah. Yeah.
All
Toes
right.
or at least like in an upright sitting position.
So, well, all right. So moving on, I got a story, and I think all three of us agreed that we all found the same story. Mount Everest has officially grown taller in 2020. So, basically, to summarize this story before I get into it, it's really hard to measure how tall a mountain is, and there can be a lot of debate, and it all kind of comes down to like, what's your definition of height of the mountain? What are you measuring to? So let's see. China and Nepal finally came to an agreement. There was a little bit of controversy over the height of Mount Everest, which is the tallest mountain on Earth. And they finally came to an agreement, and the new agreed height of Mount Everest is 8,848.86 meters, or 29,031 feet.
I have 29,032 feet
What?
in my article.
Rounding
Just-
error.
What?
Just saying.
So it used
What?
to be. Can I talk about what it
Oh,
used to be?
yeah. Okay, sure, go ahead.
So it used to, so the agreed upon, it used to be 29,029 feet, but China always had it at 29,017, and they were pressuring Nepal to accept their measurement, and Nepal basically put together an expedition and said, we're going to go up and measure it, and they put together like a team to measure it.
Mm-hmm.
And because you have to go to the top of the mountain. And do you want me to talk about how they did this?
Go ahead. But
So-
by the way, before you get into this, we have our own discrepancies because mine says that China said it was 29,015 feet.
Oh my god!
Oh man.
Can't get anything
This is
straight.
perfect. This is perfect.
This pretty much sums up the height of Everest
Yeah.
right here.
So this gets into what's called like geodetic surveying or geodesy, where you're looking at basically the surface of the earth, like the geometry of the earth, because you measure mountain height from sea level.
Yeah, some sort of datum, some sort of
So
benchmark.
sea level changes depending on where you're at.
It also
And
changes every minute of every day based on the
Every
moon.
10
and
seconds.
tides
Every
and-
time
yeah.
a wave comes in, technically your sea level goes up a little bit.
And like if you look at Mount Everest and you look at where the nearest ocean is. So the Nepalese, what they did was they basically went from, I think, the Bay of Bengal, and they created line of sight and just moved until they could see Everest.
Yeah, like that's the old school
So
engineering way to do it.
yeah, they're using what's called Theodolites, which is you're looking through, it's almost like a telescope with like a level or whatnot.
Mhm.
And you can see the angle basically off to the horizon by using some trig. If you were in high school and you thought, when am I ever going to need trigonometry? Well, to measure Mount Everest. That's why.
Duh.
And so they when they got to Mount Everest, they climbed up, and they measured like 12 different peaks, like benchmarks.
I didn't hear about this. This is new
And
to
so
me.
they measured these benchmarks, and they basically were measuring the triangles of the angles between all of these peaks, and they would hike up until they basically could get to the peak. And so they sort of did it old school, and they checked it all with GPS. Now the Chinese have their own GPS. They have their own satellites.
Their own satellites and
And
stuff.
so
yes.
the Chinese were checking it with that. And so, but it ended up, they came to this agreement where it worked out. But it's the first time it's really been measured like this. I want to say since the 70s, where they've done it with like sending an expedition and using Theodolites and things like that. They
So the new height
there was
is
a disagreement about what is the top of the mountain. Is it the rock or is it the ice on top of the mountain?
Yeah.
I don't know what they came to. I've run out of my sort of.
Well, so what they end up doing, so to kind of summarize this, China had their number, Nepal had their number, and they took the average of the two. So
that's some good. I mean, part of me is like, well, I'm glad they agreed on it, and part of me is like, well, no, there should be a number. Give me a number.
I feel like there should be an ice number and a rock number. What do you guys feel?
I think it should be the ice number, as high as it goes.
That's you're standing on the ice.
Right.
Yeah.
I get that, but at the same time, that can fluctuate. Like it's a sunny day, it moves down. It's a snowy day, it moves up. Like
maybe they just put someone there the whole time, constantly with a tape.
Well,
yeah.
So this is really interesting. So when Nepal kind of started. Nepal was looking for, like, they wanted the number. So they're doing the survey. They had 300 people that were involved on this exercise.
Yeah.
They had some people on feet, some people in helicopters, and they're working on trying to figure this out. And so last spring, Nepalese, or I guess it's Nepali surveyors got to the summit of Everest. Not only did they do the amazing feat of getting to the top of Mount Everest, which is kind of a pain in the butt. You can't. It's a bit of a task to get up there.
A little bit of a hike.
Little bit of a hike. Which, interestingly enough, the true mountaineers, they call Everest a yak trail because they don't really recognize that as like climbing, like, technical climbing. It's kind of like anyways, that's a different topic for a different day. So these surveyors got to the top of Everest with like 90 pounds of equipment, of surveying equipment, and they spent 2 hours on the top of Everest collecting data. And one of the survey guys on this team, he goes, they were interviewing him. He basically says, climbing Everest alone is a challenging task, but we also had to measure it. And this guy lost a toe to frostbite while he was doing this.
He should have propped it up on top there and added
Yeah. What toe was it? If it was his big toe, add a little bit more,
Yeah, that's another inch.
Yeah. So, and then this year, the Chinese had their survey expedition go up to Everest, but it was quieter because Everest is shut down because of COVID.
They're the only people that summited it this entire year was that survey team, right?
Yeah, that's what this article says. Yeah. So, anyways, they end up just kind of taking the average of the two. One other little interesting fact here was National Geographic had an estimate, or not an estimate. They had a they had a number for how high Everest was. They said it was 29,035 feet.
Oh wow!
But Nepal never officially recognized this number.
Huh? Because they've funded a lot of the expeditions up there, so that's where they got their number from.
Yeah, so 29,032, 29,035, 29,029. Like they're all, if you're counting snow, I feel like they're all in the same ballpark.
Maybe
I don't know how much the snow's moving around.
No, but that's what I'm saying. Like if you're not counting the bedrock that's actually uplifting from continental collision, then you're talking about some stuff that's going to be seasonal or
and that was
variable.
Part of the motivation for this was it's uplifting, and so there was talk about how much it's uplifting and what have you, but there was that big earthquake a couple of years ago.
The one that
base camp. And so they wanted to see how that affected the height of the mountain, because there was sort of competing views that had a dramatic effect on, say, uplift and where the height of the mountain was, and others who said it didn't. But it turns out we haven't sort of measured the height in a while. So, but I'm gonna just say, like, it's. You go. What are you gonna say?
Oh, you go. Finish it up. Go ahead.
I was just gonna say, well, it gets into like geodetic surveying is sort of really interesting, even though it might not seem like it. Like figuring out the height of things. Like there is no, like, you think about the Pacific Ocean. You know, what is the surface level of the Pacific Ocean? Well, if you're in California, sea level means one thing. And if you go over to Japan, it's probably higher than where you are, but it's still all the same surface level. It's all sea level, but because of wind currents pushing the ocean, you build up water on one side. So
no, I know. There's fetch and there's all that stuff. Yeah, definitely wind pressure, wind gusts. I mean, that's where waves come from.
I mean, that's why you get into. There are some people who are adamantly opposed to the idea of eustasy, which is like a single global sea level.
Yeah, no, there should be maybe some sort of global datum, but where do you put that? Because there's no place on Earth that's static.
Well, yeah. That's why it's pain in the butt to figure out.
I guess you could pick somewhere in Australia. I guess Australia has been the most static.
I'm looking at
where's the NAVD 88 located? Do you guys know?
The North American Vertical Datum.
Anyways, that's what a lot of people use for the datum.
Yeah.
So I'm just really quickly looking at a paper. I may be off on it may be tens of centimeters.
That sounds a little more
several
realistic.
Meters.
That makes a lot more sense.
It's why you get like upwelling.
Yeah.
The reason you get upwelling is you create that imbalance.
Yep.
I want to look into this more because, yeah.
Well, so I wanted to just kind of talk about some interesting numbers here, the history of figuring out the elevation of Mount Everest. So, and I had heard this story before reading this article, but when the English when they were colonizing India.
We have referenced this a few times on the podcast.
We talked about, we definitely, I thought we talked about this before, but in 1856, the British they did the survey for the height of Everest, and they did all the trig, and they adjusted for distortions in the visual distortions in the atmosphere just by looking at the summit of Mount Everest. And these guys in 1856 came up with a number of 29,000 feet, even. They came back with this number. They're looking at it and they're like, this isn't good. Nobody's going to believe us that Mount Everest is exactly 29,000 feet tall. So the story goes that they actually added on 3 feet. The number they submitted was 29,003 feet, just so that people would take them seriously and make their number more believable. So that was back in 1856. And then going fast forwarding a little bit to 1953, specifically May 29th of 1953, that's after Edmund Hillary and Tenzing Norgay Sherpa reached the summit of Mount Everest. There's an Indian survey team that readjusted that, the British estimate from back in 1856 to 29,028 feet tall. So over the years, the numbers, it just seems, so 1856, we had 29,003. In 1953, we had 29,028.
So here's a question. Were they wrong in 1856, or did the mountain just rise that much? Did the mountain rise 20 meters or 20 feet?
I don't know what the growth rate of Mount Everest is. Do you
Yeah.
know?
No, I understand, but what I'm saying is that the feat of the engineers in 1850s to measure it that precisely was pretty incredible.
All right. Let's see, 2.4 inches per year,
Yeah, it's
So over 100 years,
6.1 centimeters.
6.1 centimeters over
So
100 years.
it's half a meter, over half a meter a year. So it's
Wait, not over half a meter a year per century is what you meant to say, right?
that's what I meant. Yeah, 100 years.
Yeah.
Don't trust my numbers.
Okay.
Obviously.
Okay. Yeah. So they weren't quite on pace, but they're pretty darn close.
Yeah, it's freaking impressive what these guys were doing back in the 1800s, and
Well,
Yeah.
you know what they were using? They were using theodolites. Trigonometry, the math doesn't lie.
Right. But that's the thing. Like, they're using trigonometry, and now,
Take
like,
that, GPS.
but people are like doubting GPS, so we're using trigonometry again to ground truth the GPS.
Yeah,
Like, crazy.
turns out they're both right.
Yeah.
Yeah, I mean, people have been using, well, trigonometry for
Yeah.
3,000.
Quite a while now.
Yeah. But I think the theodolite was invented like, I want to say like the 15th or 16th century. So I've been using it for 500 years now.
Yeah. What has it done for me lately?
That, well, it measured Mount Everest like
I guess.
here. But besides that,
Yeah, besides that, I always take the
That's-
Janet Jackson route.
it's
What
interesting.
have you done for me lately?
Yeah, that's really interesting. I like stories like that.
Yeah, really, really cool.
So I'm actually just a little correction here. I'm seeing some variations in numbers
Uh-oh.
on how
Again.
fast Everest is growing. So this one says, the original one I mentioned, 2.4 inches or 6.1 centimeters a year. I'm seeing other estimates at 4 millimeters a year. So I don't know, somewhere between 4 millimeters and 6 millimeters. I know we're off by like an order of magnitude there, but
I mean, I said it was 200 meters. I meant 200 centimeters when I was talking about the ocean. So
Yeah, and even that I think is still high.
stop.
I think you mean millimeters, but still.
No, it's the one paper I was just reading is it's a meter or two.
Okay.
So
Yeah.
well, there's fun debating about elevations. Look what this podcast has turned into.
Yes.
I told you geodetic surveying, geodesy is really interesting.
It is.
What's the analogy about the Earth? If it was the size of a billiard ball, there's something like you could,
Everest wouldn't even be like a little imperfection, or you wouldn't even.
yeah, like our billiard balls have more imperfections than the
Yeah,
Earth
that's
would have
Yeah.
if they were the same size, because like the difference between the lowest and highest point is so minimal.
Yep. Crazy.
Well, I mean, so if you look at the surface of the Earth, the highest, Everest is 29,000-ish feet tall. What are we saying? It's 31 now? 29, 31? Is that
29,031.7.
All right. So
31.7,
round it up
so-
to 2032. Yeah. Okay.
all right? Whatever, 29, 32. The lowest, the Challenger Deep in the Marianas Trench, 36,000.
Well, that is also
That's
changed.
also, it's changing.
Well, I mean,
I'm sure like everybody that has their own different survey has a
yeah,
number.
because humans have only ever been down there 3 times. We've sent a bunch of submersibles, like remote, and it's really tough to get to. But it's one of those things. It depends on who you ask. 35,843.
Nat Geo says 36,201.
See, See? Who do you trust?
Oh boy, this is turning into a real kerfluffle here.
So it's a 60,000 foot differential over how many 1,000-foot diameter?
On average, 6,371 kilometers.
Kilometers.
To,
Yeah,
well, in
smack
miles.
you. Come on. We're America.
3,958 miles. So, but that's also kind of crazy. Difference. So the Earth is a oblate spheroid, right? It's not a perfect sphere. So it bulges at the center, and at the center it's 6,390, and at the poles that's to the center of the Earth. If you started on the equator and you dug a hole to the center of the Earth, but if you were at the North Pole and you dug a hole,
6,390. What
kilometers.
Oh, kilometers. Okay.
But if you were at the North Pole and you dug a hole, it would be 6,350 kilometers.
So it's not that much.
40 kilometers.
Yeah. I mean, 40 kilometers is a lot, but at the same time, we're talking about thousands of them.
Yeah.
It's not that much of a difference.
Yeah, if the Earth, the radius of the Earth is essentially 4,000 miles. So the diameter is 8,000 miles. And you're talking about 60,000 feet, which is, 12 miles. So 12 over 18 is 12 over 8,000 is. I'm gonna do the math here.
She's crunching the numbers. I hope Jesse has one of those old calculators with the with the paper.
Yeah.
0.15%.
0.15%.
Yeah.
Yeah, from the highest mountain to the lowest trench
The difference is
0.15%.
it's crazy.
That's within your 2% acceptable error.
Yeah.
But that's where the billiard ball ratio thing comes in and makes sense.
Yeah.
You have a scratch in a billiard ball, that's more than the differential.
Yeah. Patreon Frank here is talking about too. Yeah, you compare it to the surface area of the Earth, which is 510 million square kilometers, or 196 million square miles. That's nothing. Anyhow,
Thanks, Frank.
Yeah, really. Who thought measuring the height of a mountain was boring? Not me.
Boring, more like uplifting.
Wow.
That's what I'm here for, folks.
Really.
Terrible puns.
It mentally took me to new heights.
Good times.
Look at you guys. Look at this.
Yeah.
Just firing on all cylinders here.
Yeah, we're killing it.
All right. You want to do one more news story?
Yeah. Should I do the one, the big conspiracy theory one?
Absolutely. I don't know what this is, but yes, go.
I'm in.
Yeah.
Sasquatch was sighted.
It's the Thornburg show right now. Go ahead.
This a friend of ours sent us this in text, and it's from the link she sent is from Karen, fan of the show.
Oh yes.
Sent Steve and I this link, and it's NBC News, so it's a legitimate source. The former chief of space security for the Israeli government has claimed on record that aliens exist and there is a galactic federation and that world leaders know about it, and they're just waiting for us as humans to develop the technology to join the federation.
Can I just say one thing real fast? And I swear to God, this is God's honest truth. This is the second conversation I'm having today on this topic.
Wait, really?
I literally had a conversation with one of my buddies today, not about like this exact thing, but he's all into conspiracy theories, and
The
he was going
Galactic
off.
Federation. Well, I mean, it's
But he had a similar thing.
when we talked about the Drake equation, one of or the Fermi paradox, where is everyone? You know, one of the things is that the zoo hypothesis is that there's intelligent civilizations, but they're not interacting. They're just watching us to sort of see what we do. Like we're the animals at the zoo. He goes on to say that there's been cooperation agreements signed between different species, including an underground base in the depths of Mars, where there are both American astronauts and alien representatives conducting experiments. So there's an agreement between the US government and the aliens. They've signed a contract and they do experiments there.
Nice to know that the alien species has a legal system.
Yeah, they binding. It's legally binding. They're waiting for humanity to develop or reach a stage where we will understand what space and spaceships are, and where it won't create mass hysteria if they find out that there's a space federation.
This is on NBC News.
Yeah, and we'll post the link for this. So this person who is the former head of space security for the Israeli government gave this. He was the former head of Israeli Defense Ministry's Space Directorate, and he told an Israeli newspaper this. So maybe something's lost in translation here. But the guy, he's a respected professor and retired general, according to this article. Yeah, so far, both NASA and NASA has said one of their goals is searching for extraterrestrial life, but they have yet to find signs. The governments of the U.S. and Israel did not respond to comment, and the Pentagon declined to comment, which is not a denial. To stoke this conspiracy fire.
Yes.
Yeah.
I was talking to Sasquatch earlier today, and he said it was true.
So this Israeli general, head of space security or whatever, has said he thinks the time is right now. He was quoted as saying, "If I had come up with what I'm saying today 5 years ago, I would have been hospitalized. Today, they're already talking differently. I have nothing to lose. I'm respected, both at home and abroad." Okay.
Well, there you go.
Hey, listen, he's either going to be the brilliant first person to admit this, or he's not.
I will say it sort of ties in with those monoliths have been popping up everywhere.
Hey.
They have. Did we did we talk about this last week?
Yeah, the one that
the new one
in Romania. Yeah.
No, there was another one in. Oh, did I just send you guys? I emailed it to you.
Yeah, but I feel like there's been like several other ones.
Yeah. I saw one meme that showed all the symbols from the fifth element, like the wind, the fire, the water.
There's a candy store in Pittsburgh where the owner put one out in front of his store.
Nice.
Hey.
Oh, okay. Yeah, I sent you guys that link for the third one spotted in California.
Oh yeah.
Oh yeah, California, yeah.
It's copycat monoliths. Come on. What is this? Well,
yeah,
I think that's
a pretty good episode.
Yeah. I think that just about wraps it up. We're just about there with time.
Chris, for one quick second, what is that cup behind you?
Oh, wait, what is this?
Oh, yeah.
Oh, this mug right here. This may or
Get
may
it,
not.
get it in closer without a glare. Come on.
All right, so the podcast listeners can't see this, but this may or may not be the brand new Geology Flannelcast merch that we have now, coming very soon on the geologyflannelcast.com. We got ourselves some Geology Flannelcast coffee mugs.
For those of you who are listening, it is a coffee mug. It is about the dimensions of a coffee mug.
It's very good.
It is
very
a
good.
beautiful ceramic white coffee mug, but it has the beautiful Geology Flannelcast crest that has been handed down from generation to generation.
Coat of arms, if you may.
Yeah, and or we saw from someone, I don't know, Meghan Markle or something. I forget.
No. This
Sorry.
is Geology Flannelcast.
Oh, sorry, this is our Geology Flannelcast crest. It's very sacred to our being and our ancestry, I guess.
It's our origin.
Yeah, it's our origin story.
It's a great coffee. If you put coffee in it,
It will hold it and it will keep the flavor.
you would drink coffee out of it.
Yeah, and it'll keep it slightly warm too. So
yeah,
it does exactly what a coffee mug should do.
but better.
It does. But you know why it's better? Because it has our logo on the outside of it. That'll
Our
make
new
you feel
logo.
warm inside. Yes. So please keep an eye out on our website. We're eventually, hopefully, seriously,
Hopefully by the time this podcast comes out, it'll probably be very shortly afterwards.
Yeah.
We'll have this up on the website. But for right now, if you'd like to help out with the podcast, obviously we've always been talking about helping out, becoming a Patreon sponsor. We have several different tiers at different rates. If you want to sponsor the podcast, that way you can come in, hang out, watch us record the podcast, ask us any questions, or just hang out, talk with us before and after each episode. We got some other tiers. You get some stickers out of the deal, or you can go to the merch link on geologyflannelcast.com. You can get some Geology Flannelcast stickers on there, and like I said, very soon we'll have these mugs up there. So
yeah.
First of many things of merch.
It's funny. I told my significant other about that we were starting to sell stuff on the website. She's like, "Oh, you're starting to sell merch?" I was like, "Yes." I called it merchandise, and Chris called it merch, and she's like, "That's everybody calls it merch now." So yes, it's called merch.
Merch. Make it shorter.
Merch. Sorry. So that's just old Steve not knowing what merch was.
Get with the times, man.
I know, right? I'm so old.
So, what else? Check us out on, let's see. Like I said, our website's geologyflannelcast.com. Our Facebook page is, Geology Flannelcast on Facebook. Twitter, we're at GeoFlannelcast. And
If you like us, why not support us?
Yeah. Right? Come on. What have you done for us lately?
No.
They've listened to us and have been very supportive over the years, and we're very appreciative of it. So, all right, let's end this before Steve can ruin this anymore.
I love you guys. No, seriously, thank you for listening. Thank you for subscribing. Thank you for downloading. Thank you for being any sort of participation level. I appreciate it. I was only kidding.
Also, if you have any geology questions, you can submit them at geologyflannelcast.com as well. And then every once in a while, we do a listener questions episode. So we just did one a couple of weeks ago, and as soon as we get enough kind of in the inbox there, we'll do another episode. We love doing those. Those are always fun, and you guys ask some really, really awesome questions that are always. Every time we go through that list, we're always very impressed by the caliber of questions.
But also to fast track that, we have a Patreon level where you can just shoot us a question and we will answer it. So,
well, if you become a Topaz Patreon level member, You get your own show. You ask us. If you want to sponsor us to that level, you pick a topic and we will do an entire episode on that topic.
Yeah.
So we've done a couple of those already, and hopefully many more to come. So
yep.
All the different ways you can help out with the Geology Flannelcast. So, all right, everyone, thank you so much for listening. And we love you guys, and we'll catch you guys next week on another exciting episode of the Geology Flannelcast.
Thanks for listening.
All right. See you, everyone. Bye.